So now students, in the previous lecture we discussed about factors and find factors by using prime factorization and about SCF. Now here we will discuss about multiples, right? What are the multiples here? Now here we write the definition of multiple. A multiple of a whole number is the product of the number and any counting number, right? So here we write the definition of multiple. A multiple of a whole number is the product of the number and any counting number. So now here we write some multiples of 2 and 6, right? Now first we write multiples of 2. So what we do here, if we multiply 2 with natural numbers, so here we get multiples of 2 here. So what we do here, 2 ones are 2, then 2 multiply with 2, 2 twos are 4, and 2 multiply with 3, 3s are 6, and 2 multiply with 4, 4s are 8, 2 multiply with 5, 5s are 10, and so on. Right, we apply the same rule with when we find the multiples of 6 here. Multiples of 6. So here we multiply 6 with 1, here we get 6. 6 multiply with 2, here we get 12 here. Now 6 multiply with 3, we get 18 here. 6 multiply with 4, we get 24 here, and so on. Right, so by using this method, here we get the multiples of the numbers here. Right, so if we say that a multiple of a whole number is the product of the number and any counting number, right? Now here we write one important note related to multiple, right? The first point is 0 is a multiple of every number. Multiple of every number. Now the second one is the smallest multiple of any number other than 0 is the number itself, right? So here we write the smallest multiple of any number other than 0 is the number itself. Now the third one is the number of multiples of a given number is infinite. Right. So these are some important points related to multiples here. Now here we will discuss about least common multiple. LCM, right? Least common multiple. So here we have the definition of least common multiple. So here first we will discuss if a number is a multiple of two or more numbers, it is called a common multiple of the numbers, right? So here we write if a number is a multiple of two or more numbers, it is called common multiple of the numbers, right? So here the so if a number is a multiple of two or more numbers, it is called the common multiple of the numbers. So here we take one example here, like 3 4s are 12, right? 3 4s are 12 and 4 3s are 12. So here we say that therefore 12 is a common 12 is a common multiple of 3 and 4, right? Now here we write the definition of LCM here, right? What is the definition of LCM? So here we write the smallest number other than 0, that is a multiple of 2 or more counting numbers is the least common multiple LCM of the numbers, right? So there are different ways to find the LCM of two or more numbers here. Here we discuss first three methods here by listing the multiples. Second one is by prime factorization, and the third one is by division method, right? So here first we will discuss here by listing multiples. So now here we take first method here, method number 1, by listing the multiples, right? So now here we find the LCM of 6, 8 and 12 here, right? Here we find the LCM of 6, 8 and 12, right? So what we do here, first we write the multiples of 6, multiples of 8 and multiples of 12 here, right? So here we write the multiples of 6 equal to 6 1 is 6, 6 2 is 12, 6 3 is 18, 6 4 is 24, 6 5 is 30, 6 6 is 36, yes, 6 7 is 42 and 6 8 is 48 and so on. Now here we write multiples of 8, right? 8 1s are 8, 8 2s are 16, 8 3s are 24, 8 4s are 32, 8 5s are 40, 8 6 are 48, right? And so on. Now we write multiples of 12. 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are 48, 12 fives are 60 and so on. Now here we mark common multiples, right? Common multiples from 6, 8 and 12 here. Now 6, no, 6 is not common multiple here. Now 12, 12 is here but 12 is not here, right? Now what about 18? 18 is not here, so here we not take 18 as a common multiple here. What about 24? 24 is a multiple of 6, 24 is a multiple of 8 and 24 is a multiple of 12. So here we write common multiples are, first one is 24. So now what about 30? 30 is not here. 36, no, 36 is not a multiple of 8. Now 42, no. What about 48? 48 is a multiple of 6, 48 is a multiple of 8 and 48 is a multiple of 12. So here we write 48 here. Now when we find the other multiples of 6, 8 and 12 here, so here we get 72 also, right? And the other multiples. So dear students, you all know that out of these all multiples, here we take the least one, right? So what is the least multiple of, and you also say that the smaller one, right? Out of these all three multiples here, which one is smaller? 24. So here we say that LCM of 6, 8 and 12 is 24, right? So here we say that LCM of 6, 8 and 12 is 24. Here we use the first method here by listing the multiples, right? Now you also find the LCM of different numbers by using this method. Now the method number 2. And the name of this method is by Prime Factorization. By Prime Factorization, right? Now here, so now students, here we find the LCM of the same numbers, right? Here we write find the LCM of 6, 8 and 12, right? So what we do here, first we find the prime factors of 6, then 8 and then 12, and after that here we take common factors here and the other factors also, and we multiply these all factors here and we get our LCM. right? So we start with 6 here. Now here we use division method here to find prime factorization. So we write 6 here, and 2 3s are 6 and 3 1s are 3, right? So here we get the factors of 6 equal to 2 multiplied by 3. Now what about 8 here? So here we take the second number 8. Now start with 2 here. 2 4s are 8, 2 2s are 4, and 2 1s are 2. So now here we write 8 equal to 2 multiplied with 2 multiplied with 2 here. Now here we write 12. Now 12. So here we divide this 12 by 2. 2 6 are 12, 2 3s are 6, and 3 1s are 3. So now here we write 12 equal to 2 multiplied with 2 multiplied with 3. So now here we take common factors here, 2 2 and 2 here, right? Then the other factors, here we write common factors here, right? So what are the common factors here? First we write common factors here, 2, then there are pair of 3 numbers here, now 2 numbers here, and 3 and 3. So here we write 2 multiply with, here we write in the place of these 2, here we write only 1 2 here, then these 2 3, here we write 3 only. So first we write common factors here. So here we take in the place of these 2, here we take 1 2 here, in the place of these 2, here we take 1 2 here. Now in the place of these 3 here, here we take 1 3 here, and because 1 2 is left here, so here we write here. So 2 2s are 4, 3s are 12, and 12 2s are 24. So here we get 24 here when you multiply these all factors here. So here we get LCM equal to 24, right? So here we say that when we find the factors of 6 8 and 12 by using prime factorization, here we get LCM equal to 24, right? Now we take another method, and the name of this method is by division method. Now the third method is by division method, right? So here we find the LCM of 6 8 and 12 here, right? So now what we do here, here we find the LCM of the numbers, right? So here first we divide and we write these all three numbers like this here, 6 8 and 12, and after that, now here we write these all numbers like this and start with 2. Here we divide these all numbers by 2. 2 3s are 6, 2 4s are 8, and 2 6 are 12. Now these two numbers are divisible by 2, so here we divide this number by 2, and here we write other numbers as it is here. 2 2s are 4 and 2 3s are 6. Now here this 2 divisible by 2, so here we write these numbers as it is here, and 2 1s are 2 and 3 right as it is. Now 3 1s are 3, here we write 1 as it is here, and 3 1s are 3. Now here we write these all factors here, right? So here we write 2 multiply with 2 multiply with 2 and multiply with 3. So when we multiply these all numbers here, 2 2s are 4, 2s are 8, and 8 3s are 24, right? So if we say that LCM of these three numbers 6 8 and 12 is equal to 24. Now students, you observe one thing here. Yes, you notice one thing here. When we find the LCM of these three numbers 6 8 and 12 by the different methods, by listing the multiples, by prime factorization, and by division method, so here we get the same LCM here, 24. Okay, so here we use any method and find the LCM of the given numbers. right? So here we take some another examples here related to find the LCM of given numbers by the different methods. Now here the question is find the LCM of, right? So the number are 9 and 12, and here we use by listing multiples, right? So now in the solution here first we write the multiples of 9 here, right? Multiples of 9. And what are the multiples of 9 here? 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36, 9 fives are 45, 9 sixes are 54, 9 sevens are 63, and so on. Now here we write the multiples of 12 here, and multiples of 12 equal to 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are 48, 12 fives are 60, 12 sixes are 72, and so on. Okay. Okay, so now here we write the common multiples here. Common multiples of 9 and 12. So what are the common multiples here? Okay, so here we get 36 here, 36 here, so here we write 36, right? And here we write only 36 here. Why we write only 36 here? So dear students, you all know that here we choose the least multiple here. Least mean the smaller one. And which one is the common multiple here, which is smaller? 36 here. So here we say that LCM of 9 and 12 equal to 36, right? Now here we take another question. 15 and 48, and here we use method by prime factorization, right? So what we do here, first we find the prime factors of 15 and after that 48. Okay, so here first we start with 15 here. Now we find the factors of 15. So here we divide this 15 because 15 is not divisible by 2. So here we check divisibility by 3 here, and 3 fives are 15 and 5 ones are 5. So here we get prime factors of 15 is equal to 3 multiplied by 5. Now we find the prime factors of 48 here, right? So here we divide this number by 2. Okay, so 2 twos are 4 and 2 fours are 8. Now again divide by 2, 2 ones are 2 and 2 twos are 4. Now again divide by 2, 2 sixes are 12. Now again divide by 2, 2 threes are 6. Now divide by 3, 3 ones are 3. Now here we write 48 here. Now here we multiply 2, multiply with 2, multiply with 2, multiply with 2, and multiply by 3. You all know that here first we write the common factors here. So here is 3 and 3 is common here. So here we write only 3 here, and after that here we write left numbers here, right? So 2 multiply with 2, multiply with 2, and multiply by 2, 4 times 2 here, and multiply with 5. Now here we multiply these all numbers here. 3 twos are 6, 6 twos are 12, 12 twos are 24, 24 twos are 48, and 48 fives are, now here we multiply 48 and 5 here. 8 fives are 40, 0, 4 carry here, 5 fours are 20 plus 24. Here we get 240 here, right? So here we say that LCM of, okay, here we write LCM of 15 and 48 is 240. Right. Now here we take another example here. Find the LCM of 18, 42 and 48 by division method. Okay, so here we divide these all three numbers and start with 2 here. Right. Now start with 2. 2 9s are 18, 2 2s are 4 and 2 1s are 2, 2 2s are 4 and 2 4s are 8. Because these two numbers are not divisible by 2, but this 24 is divisible by 2, so here we divide this 24 by 2 and here we write other number as it is here, 9 and 21. Okay, now 2 1s are 2 and 2 2s are 4. Now here this 12 again divide by 2, so here we divide 12 by 2. 2 6 are 12, right? Then here again we divide this 6 by 2. 2 3s are 6. Okay, now by 3. 3 3s are 9, 3 7s are 21 and 3 1s are 3. Now here again 3 1s are 3, here we write 7 as it is here and here 1. Now 7 1, 7 1s are 7 and 1 here. Now here we write these all factors here, 2 multiply with 2 multiply with 2 multiply with 2. Now total to 4 times here. Now 3 multiply by 3 and multiply by 7. Now here we multiply these all numbers here. 2 2s are 4, 2s are 8, 2s are 16 and 16 3s are 48 and 48 3s are 144. So here we multiply 48 and 3 here, 8 3s are 24, 4 to carry here, 4 3s are 12, 13, 14, 144. 144 multiplied by 7. Now here we multiply 144 and 7. 7 4s are 28, 8 to carry here. 7 4s are 28 plus 230 0, 3 carry here. 7 1s are 7 plus 3 10. So here we write 1008, 1008, right? So here we write LCM of these three numbers 18, 42 and 48 is equal to 1008, right? So here we use division method and find the LCM of the given numbers. We'll discuss another important terms and rules related to divisibility, right? So here we discuss some divisibility rules here. Okay, so by the help of these divisibility rules, here we check the number is divisible by the given number or not, right? So here the first rule is here we check divisibility by 2. So divisibility rule of 2 say that a number is divisible by 2 if its unit digit is divisible by 2, right? And in another way, if the number is even, that is one's digit is 0, 2, 4, 6 or 8, right? So here we write, so if we write divisibility rule of 2, a number is divisible by 2 if its units digit is divisible by 2. By 2. right? Here we take one example here, like number 254, right? Because here the digit in unit place is 4 here, and 4 is divisible by 2, so here we say that this number is divisible by 2. Now here we take another number 132, right? So digit in a unit place is divisible by 2 here, so if we say that this number is divisible by 2 because the digit in a unit place is also divisible by 2 here, right? Now here we take the next rule here, and this rule is related to 3, right? Divisibility by 3. So divisibility rule of 3 say that a number is divisible by 3 if the sum of its digits is divisible by 3, right? So here we write the definition here. A number is divisible by 3 if the sum of its digits is divisible by 3, right? Now here we write example like number 384, right? 384. So what we do here, first we add these digits 3 plus 8 plus 4, and if the sum of these digits is divisible by 3, so here we say that this number is divisible by 3, right? 8 plus 4 12 plus 3 15, so here we get sum equal to 15 here, right? And 15 is divisible by 3, so here we say that yes, the number 384 is divisible by 3. Now here we take another example here, like 217095, right? 2,17,095, right? 2,17,095. So now first we add these all digits here, 2 plus 1 plus 7 plus 0 plus 9 plus 5, right? After that we add these numbers here, so 2 plus 1 3, 3 plus 7 10, and 10 plus 9 19, and 19 plus 5 24, right? Here we get 24. So 24 is divisible by 3. 3 8s are 24. So we say that here's this number divisible by 3. Okay. Now here we discuss the next third rule here. Divisibility rule of 5. Divisibility by 5. Right? Divisibility rule of 5 is a number is divisible by 5 if its unit digit is 0 or 5, right? A number is divisible by 5 if its units digit is 0 or 5, right? Here we take one example here. So here we take number like 2370. So here we observe the unit digit is 0 here, so here we say that yes, this number is divisible by 5. So the whole number means 2370 is divisible by 5. Now here we take another example here. 5455, right? So here the unit digit is 5 here, so here we say that yes, the number 5455 is divisible by 5. Now here we will discuss next divisibility rule here. Divisibility by 9. By 9. So here the divisibility rule of 9 is similar to the divisibility rule of 3. A number is divisible by 9 if the sum of its digit is divisible by 9, right? So here we write a number is divisible by 9 if the sum of its digits is divisible by 9. We take example here. Now number like 7326, right? 7326. Now what we do here, first we add these all digits here, and here we get as a sum 7 plus 3 10 plus 2 12 and 12 plus 6 18, and 18 is divisible by 9. 9 to the 18, so here we say that yes, the whole number 7326 is divisible by 9. Now we take another example here. 360, right? First we add these all three digits here, and here we get as a sum 9, and 9 is divisible by 9. 9 was a 9, so here we say that the number 360 is divisible by 9. Now here we will discuss next rule, divisibility by 10. Divisibility by 10, right? So a number is divisible by 10 if its unit digit is 0. So here we write a number is divisible by 10 if its unit digit is 0, right? Now here we take example here like 100, because 100 having unit digit 0 here, so here we say that yes, this number divisible by 10, right? Now like another example, here we take the same example here, 360. So this number having unit digit 0, so here we say that 360 is divisible by 10. Now we discuss another divisibility rule here, divisibility by 11, right? In this rule, a number is divisible by 11 if the difference of the sum of its digits in odd places and the sum of digits in even places, okay, and starting from the units place is either 0 or divisible by 11. So we say that the number is divisible by 11. Now here we write a number is divisible by 11 if the difference of the sum of its digits in odd places and the sum of digits in even places and starting from units place is either 0 or divisible by 11. Divisible by 11. Right. Now here we take some example here. So here we write number here, number, sum of digits in odd places and sum of digits in even places, and here we write difference. Okay, so now here we take first number here, 3465. So here we add digits in odd places, so 5 and 4 in odd places, so here we add 5 plus 4 here we get 9, and after that here we add digits in even places, so 6 and 3 in even places, so here we write 6 plus 3 9, and here we get difference 9 minus 9 equal to 0. 9 minus 9 equal to 0. So because here we subtract these two numbers here, sum of digits in even places and sum of digits in odd places, right? So here we get 0. So if we say that the number 3465 is divisible by 11. Now here we take another example here, and the number is 95,986, right? So here we apply the same rule here. Here we add digits in odd places like 6, 9 and 9, right? So here we add 6 plus 9 plus 9 here, and here we get sum 24, and after that here we add 8 plus 5, and here we get 13. Right, now we subtract these two number here, 24 minus 13, and here we get difference 11. And dear students, 11 is divisible by 11. 11 is 11. So if we say that the number 95,986 is divisible by 11. Now we discuss next rule here, divisibility by 4. Now the next rule, divisibility by 4. Divisibility by 4. Right, so here a number is divisible by 4 if the number formed by its digits in tens and unit places is divisible by 4. So if we say that the number divisible by 4, so a number is divisible by 4 if the number formed by its digits in tens and units place is divisible by 4, right? Here we take one example here. Now, like 80,000, here we write 80,372, right? So here the digits in unit and tens place, ones and a tens place is 72, and the number formed by these two digits is 72 here, right? And 72 is divisible by 4. 72 is divisible by 4. So if we say that the number 80,372 is divisible by 4, right? Now here we take another example here, like 360. Okay, so digits in a units and tens place 0 and 6, and the number formed by these two digits 60, and 60 is divisible by 4. 4 ones are 4 and 4 fives are 20. So if we say that yes, the number 360 is divisible by 4. Now the next rule is divisibility by 8. Divisibility by 8, right? This rule is similar to 4, but here we take 3 digits here, 1, tens and a hundred place, right? So here we write a number is divisible by 8 if the number formed by the digits at the hundreds, tens and units place is divisible by 8, right? Now here the example, and the number is 2,07,608, and digits in units, tens and hundred place is 6, 8, 0 and 6, and the number formed by these three digits 608, and 608 is divisible by 8. Okay, 8 sevens are 56 here, 4 is left here, right? Now here we take 8 here, and 8 6 are 48. 8 6 are 48. Now here we get 0 remainder. So we say that this number 608 divisible by 8. So if we say that the whole number 2,07,608 is divisible by 8. Now here we discuss another important divisibility rule of 6. Okay, so now divisibility by 6, right? So the rule is a number is divisible by 6 if it is divisible by 2 and 3, both the numbers. It should be an even number, and the sum of its digit should be divisible by 3, right? So here we write a number is divisible by 6 if it is divisible by both 3 to the 6, so it means 2 and 3, both the numbers. So that is, it should be an even number and the sum of its digits should be divisible by 3. So now here we take one example here, 68,370. Now here we check, because the digit here, first we check by 2, okay, and after that 3. Now divisibility rule have to say that if the last digit is even, okay, the last digit is even or 0, right? So the whole number divisible by 2. So if we say that yes, this number 68,370 is divisible by 2 because unit digit is 0 here. Now here we check divisibility by 3. So here first we add these all digits here, 6 plus 8 plus 3 plus 7 plus 0, and here we get sum 6 plus 8 14, 14 plus 3 17, and 17 plus 7 24, and you all know that 24 is divisible by 3. So if we say that yes, this number divisible by 3. So here we say that this number 68,370 is divisible by the both number 2 and 3. So we say that the number divisible by 6. So we say that 68,370 is divisible by 6, right? Now the next rule, divisibility by 25. Divisibility by 25. So divisibility rule of 25 say that a number is divisible by 25 if the number formed by the digits at the tens and a unit places is divisible by 25. So here we write rule here, a number is divisible by 25 if the number formed by the digits at the tens and units places is divisible by 25, right? Here we take one example here. So now here we take number 8,750. Now here we take first number 8,750. So here the digits in ones and tens place is 0 and 5, and the number formed by is 50, and 50 is divisible by 25. So if we say that number 8,750 is divisible by 25. Now here we take another number here, 23,275. So here the digits in unit place is 5 and tens place is 7, and the number formed by these two digits is 75, and 75 is divisible by 25. So if we say that the number is divisible by 25. Okay, so now students, here we use these all rules here, divisibility rules here, and here we find the number is divisible by the given numbers or not, right?